How virtual threads works internally in Java? Well, this might be your next Java job interview question, but don't worry, I got you covered in this video. With Java 21, we got two types of threads, platform thread and virtual thread. In this video, we're gonna compare both of these things and we will build a solid multi-threading foundation. So let's get started. Guys, imagine we have three layers right now. One is our JVM layer, one is OS layer, and one is CPU layer. Okay? You can imagine like we have these three boxes. This box managed by JVM, this box managed by the operating system, and this box managed by the CPU. Okay? Imagine you are going to create a thread object. When you create a thread object, there are a few things associated with it. The first thing is the run method. It is going to hold the code that you want to run, okay? And every thread, whenever you start it, you got a memory, a stack memory basically, where the thread is going to keep any local variables or any method frames or any addresses, all those things which are related to this code, it is going to keep those things inside this memory, okay? So every thread has a stack memory, and that's why I say whenever you start a thread object, as each thread has a memory associated, this is basically a heavyweight object, right? So once you start the thread by calling the start method, it is basically going to be assigned to a OS thread. So when you create a thread on Java, you are basically ended up creating a thread in OS label. Right after the OS thread got created, your OS thread will be managing this thread object that you have created in your JVM. Okay? Basically, the operating system, that's your OS, this is going to schedule this thread and it's going to assign it to your chip or to your CPU. So your OS thread then further has been assigned to a core, your CPU core, or to a chip, whatever you can imagine. Right? You have 2-core, 3-core, 4-core CPU. So imagine this is one of the core where this thread will be executed. Okay. Now the operating system takes over this Java thread, schedule this to one of his core, and then this particular thread object executes. Like you can treat those normal thread objects right now as platform thread. If you're using Java 21 or 24, we call those thread objects as platform thread. So as I have told you, platform thread has a 1:1 relationship with the OS thread. So whenever you create any normal thread, that's the platform thread, okay? And that's heavyweight in nature because every platform thread comes with a memory. And like when you create more and more platform threads, okay, to execute your run method or the code that you have over here, each thread has a memory assigned to your platform thread, okay? And whenever you're gonna start all this, threads, as I said, it has a 1:1 relationship with the OS thread, and you will be ended up creating new OS threads over here, and all these OS threads right now will be assigned to CPU core in order to execute all these platform threads. All your platform thread will run, and all this platform thread related data will be stored in the memory, which is the stack memory. Okay. And this is how exactly when you run a thread, this is how exactly the thing basically happened behind the scene. Now, with respect to this slide, I have few questions. Tell me true or false. Okay. Platform threads are heavyweight in nature. Correct or wrong?
Yes.
Correct, right? Okay. Tell me, once you create a thread object, okay, your operating system threads only manage it behind the scene. This statement is correct or wrong?
Yes, correct.
Correct, right? So can we say the platform thread and the OS thread has a very thin layer and there is nothing much is going on? We are creating a platform threads, means we are ended up creating a OS thread. And that's why we're saying you cannot create so many of platform threads because your OS will not allow you to create so many of OS thread behind the scene. Now from the Java 21, we got another type of threads in Java. And that's what we call the virtual thread. Okay. Even it is available before Java 21 as a preview feature, but from Java 21, it just got stable. Okay. Right now, you guys can use it in production, but I know most of you guys are still using Java 11, or maybe some of you are using Java 17, very rarely, because that's the industry standard right now. Because after Java 8, Java 11 used to be the stable version, and after Java 11, Java 17 used to be the stable version. Now, once you see when your next project migration will happen in your company, you will move to the Java 21 and will be start using all these features, right? So it's good to know about that. So the new types of threads that we have in the latest Java version, like Java 21 or 24, that's called virtual thread. Now, when we say a virtual thread, it also does the same thing as platform thread. It executes some task. So the virtual thread also holds a run method. If you think like a virtual thread, you can think like there is a run method where you have written some code. And those code you want to run using this thread, okay? But what you don't need to assume here, the virtual thread has a stack or has a separate memory allocated. No, this is not true. So the virtual thread doesn't have any specific stack memory. If the virtual thread doesn't have any stack memory, now how it is going to store the data? Because whenever the run method will execute, imagine there are some lines of code over here, and you are using some, you are calling some other methods, you have some local variables, how the method stack frame will be stored in the memory, or how the local variables that you are using over here in this code, how that will be stored in the memory. We will talk about that in the next slide. But for now, imagine the virtual thread doesn't have any specific memory attached with it. That's why we say it a lightweight thread. You can actually imagine in the Java heap, the virtual thread is just a normal object, like you are creating any objects in Java, any custom objects in Java. Just like that, you have this virtual thread, which is also like a Java object, right? Right now, you can think, as this is a lightweight thread, you can actually create so many of virtual thread, okay? And all these virtual threads you will create on top of the JVM. You can think we are creating all these threads over here in the JVM label. And you don't have to worry, like for each virtual thread, there will be any operating system thread. No. So you can create so many of virtual thread, and your operating system is unaware about all these virtual threads that you are creating. Okay. Now, as this is a normal, Java object, you can think like whenever the virtual thread will be done with its work, just like any other Java object, once this is deallocated with the memory, the garbage collector, this monster will eat this up. Okay. Just like this. Let's say this is another virtual thread done with its task. This garbage collector will clean it off from the heap space. And this is how mostly, how your GC works in Java. Okay. Now let's just see. This is all about creating a virtual thread. Okay. And I told you two things. Virtual threads are lightweight in nature. Why it is lightweight in nature? Why the virtual threads are lightweight in nature? Anyone?
It's not taking too much of memory, and also it is storing in heap, and its size is very less.
Exactly. And mostly the virtual thread doesn't have any stack involved over there, right? Because as I said, if you're going with the platform thread, every thread has a stack associated with it. And let's say each stack can have 1 MB of memory. You can increase or decrease it, by the way, but every stack will have some memory. Let's say 1 MB of memory if you're associating with one thread, and if you keep creating the platform threads, then with, let's say, 1,000 platform threads, we need to basically waste 1 GB of memory. Here in the virtual thread, as there is no stack involved over here, it is very lightweight, and you can create as many of the virtual threads that you want to create. Only one takeaway is that the virtual threads I'm creating in the JVM label. And whenever I'm creating the virtual thread, the operating system has no role scheduling those threads, not like scheduling those threads. Yeah, I can say the operating system doesn't know about that. So it has no role scheduling of virtual threads as well. Okay. Now let's just see how these things works internally. Okay. Because we have just seen how virtual threads got created. Now, how actually they are going to run in real time. So again, 3-layer JVM, OS, and CPU. CPU has all your cores, which will help your threads to run. Your operating system, this will be basically helping you to create different threads, and those threads will run on this chip or on this 4-core CPU that you are seeing over here. Now let's just go to the JVM label. Imagine you are creating a virtual thread. Whenever you're going to create a virtual thread and whenever you want to run that, behind the scene, there is a pool of platform threads available. Like these are all your normal Java threads, and you can see a pool of platform threads are available over here. Why? Because this virtual thread will run on top of the platform thread. Like here I have 4 platform thread. Why I have created 4 platform threads here? Because by default in Java, if you are using a 4-core CPU, your JVM in the JVM label will create a pool of 4 platform threads. You can think like this is equal to the number of processors available. Okay, number of available processors. You can think like that, because these are the maximum number of threads which can run at a time. Parallelly, you can think like if you have 4 threads, only 4 threads can run at a time if you have 4 core. Even if you are creating 100 threads, those 100 threads cannot run at a time. By the way, let's come back to the reality right now, because we are not talking about platform threads. All this platform thread pool will be created by JVM behind the scene. Okay. Why it is creating a pool of platform threads behind the scene? In order to run the virtual threads that you are creating. Because the virtual thread, how it will run, let's say it will do something, but how it will run, to run virtual thread behind the scene, all these platform threads will be needed, and all these OS threads also will be needed. It works like this. The platform threads will be mapped to the OS threads. This platform threads, by the way, as I said, created behind the scene, and 4 platform threads mapped to all the 4 OS threads. Simple thing, there is a 1:1 relationships, as I said. So the number of platform threads that you are creating in the OS label, that many threads will be created. And whenever a virtual thread you want to run, it will be mounted to a platform thread. Well, when the virtual thread will be associated with a platform thread, okay, because it wants to run this process, what we call mounting. And one more thing, once the virtual thread associated with a platform thread, in order to get itself running, that platform thread is called as a carrier thread. Carrier threads means this virtual thread will work on top of this thread. Okay. And this carrier thread, whenever you hear it, you think like this is the platform thread only. Okay. So right now we have mounted this thread over here on top of this carrier thread. Now this OS thread will be given to one of the processor or one of your CPU core. And now the virtual thread will be executed like this. Once the virtual thread's done with its execution, right now, let's say it's done with its task, then this mounting will be, unmounted, right? Now you can think there will be an unmounting process will begin, or we say this unmount. Now, when you say unmount means this association will be gone right over here from the scene. Now this virtual thread is simply a normal Java object which lost its reference, right now ready to be garbage collected. Now you can think your garbage collector will kick in and will eat this virtual thread and is gone from the heap memory. Okay, this is how it works. Now let's say there are so many virtual threads that you have created right over here. Now see, I have created a virtual thread called virtual thread 2. Now you can think like the same virtual thread right now, if it wants to run, it can use the same carrier thread which has been used before. So you can think like all these carrier threads that we have created, they are getting reused. Okay. So imagine now this virtual thread 2 has been mounted with this carrier thread, and now it can finish its execution and then get itself unmounted. And then the garbage collector will eat that particular thread. Okay. I have one question. Virtual threads are created in heap memory or stack memory?
Heap memory.
Heap memory. Okay, cool. What do you mean by unmounting?
Detaching, maybe you can say.
Yeah,
Detach.
detaching the virtual thread. Okay. What do you mean by a carrier thread?
Whenever we are mounting,
Whenever we're mounting?
whenever we are mounting a particular virtual thread with a platform thread, that time we are calling that as a carrier thread.
Yeah, we're calling that platform thread as a carrier thread. Okay. Now tell me, virtual threads behind the scene uses a OS thread to run. Is that a correct statement or not a correct statement?
Correct. Yes. Yeah, correct. It's correct.
Correct statement, right?
Yes.
Virtual thread has a 1:1 relationship with the OS thread. Correct statement or wrong statement?
No.
Wrong statement, right? Because we can create many virtual threads, but behind the scene, virtual thread uses a thread pool of career thread only. So that career thread will have a 1:1 relationship with the OS thread. But the virtual thread is actually created on the JVM label, and the JVM basically decides how to mount it on a career thread. So behind the scene, this OS thread doesn't even know that on top of it, JVM is creating a virtual thread. Okay. The scheduling of the virtual thread will be completely on the JVM. But whenever you remember, whenever I have given you the platform thread example, when you had used to have a 1:1 relationship with the platform thread with the OS thread, that time you can think like the OS thread will schedule the carrier thread or the platform thread, but not the virtual thread. Okay, cool. You guys are on track. Now, let's just go to the next step. Now imagine we have so many virtual threads over here. Okay. Now the question that I do have over here, how all these virtual threads will work in real time. As you guys know, this will have a reference to a platform thread. That means all these virtual threads will be mounted to a platform thread. And all this platform thread right now will be connected to the OS thread, and all these OS threads will be further connected to the core. That means the OS will be scheduling all these OS threads that we are creating over here, and will schedule it and will give one processor to it. Okay. Now, once the virtual thread will be attached with the platform thread, we call this a carrier thread. And you can already see that all these carrier threads has a stack involved with it. That means when all these virtual threads will run, they will store the data inside the carrier thread stack memory. That's why I said, like, the virtual thread are the objects in the heap, but the virtual thread doesn't have any specific memory. Now the virtual thread will be attached to the carrier thread, and the carrier thread does have the stack memory. So the virtual thread uses the stack of the carrier thread where it is going to run. Okay. And then let's say here, all these threads are mounted right now. Now we have 4 carrier threads. That means 4 virtual threads has been mounted. You have to remember this point. One virtual thread at a time can run on top of one carrier thread. Okay, that's the takeaway. Don't assume like on top of one carrier thread, 10 virtual threads can run at a time. No, on top of one carrier thread at a time, only one virtual thread can run. If you have hundreds and thousands of virtual threads, then other threads like virtual thread 2 and the virtual thread 6 does have to wait right now. Okay, these two guys will wait when all these other 4 threads will run because they are mounted over here. Now you have no control how this mounting will be done. That will be done behind the scene in a JVM level. Okay, JVM will schedule which virtual thread will be mounted to which of the carrier thread. Okay, now all these virtual threads will run right now. And while it is going to run, the other virtual threads got to wait. Now, once this is done, they will be unmounted from the carrier thread on top of what they are running. They will be eaten off by the garbage collector, assuming the case that, they have completed their execution. And let's say these are the 2 virtual threads which are remaining right now. Now they can be again scheduled by the JVM on top of other 2 carrier threads. Maybe the same carrier threads can be used over here, and now they will run. And once this is done, the garbage collector again is going to eat them up. Okay. This is how all your virtual threads will be scheduled by the JVM. Okay. And as a developer, you have a very little control on that. Okay. So Avnik, you had a question if you want to ask me.
Yeah, Avila. So I was saying that you mentioned whenever we are creating any virtual thread,
Mm-hmm.
automatically the pool is getting created. I mean,
Correct.
that pool will be created by JVM.
That pool will be created by JVM only because you can think this, you can see this green line, right?
Mm-hmm.
See, this is the JVM. For the JVM, I have created this green line. This pool will be created inside the JVM. And this is a fork join pool where number of platform threads the JVM will create in order to run your virtual threads.
Vilas, so this pool, that ForkJoin pool will be created only when we are trying to create virtual thread. Uh,
Exactly. That is the
okay,
point. When you
okay.
when you actually run the virtual thread, then only this pool will be created. You are just creating virtual thread, not running it, then this pool, I think it will, Debian will not create this pool. At least one virtual thread you need to create and try to run in order to make this pool created. And actually Java 24, the latest version of Java has some feature so that using that you can monitor how this pool is getting created and all. We'll be doing that as well. Okay.
Yeah, Vilas, okay.
Making
That
sense?
was my question. Yeah, yeah, correct.
Yeah. Any other questions? Savnik, any follow-up questions?
Not yet, Vilas.
Okay. Anybody else having any other questions with this slide? You
Uh,
guys are good?
Avinash,
Uh-huh.
I have one question.
Yes.
Virtual, like our normal thread have a life cycle, or does virtual thread also has a life cycle, or it is something else?
You can think like everything that you have learned on Java multithreading with respect to the normal thread or the platform thread, everything applied to the virtual thread. Okay. Right from your life cycle, concurrency, locking, synchronization. Like if you have explored those things, then everything is applied to this. And in the latest version of Java, in previous methods that we used to have in Java, like sleep method, let's say other methods, they all are getting updated with respect to virtual thread. Okay, so you can treat virtual thread as a normal thread only, but the virtual thread is actually assigned when it is going to perform some IO bound operation. Then only you have to use the virtual thread. If you are just doing CPU bound operations like executing a loop or image processing, then you don't have to use the virtual thread because that will not mean anything, right? You have just ended up creating so many virtual threads, but that's not needed. Let's say you are just executing, you have a method, in that method you're just running a loop and you want that loop to be executed by 4 different threads. Blindly go with the platform threads. Okay, if virtual thread is so crazy, then Java people might have completely removed the platform thread in the recent version. But in the recent version, the platform thread also exists. With respect to that, there is one more addition, and that's the virtual thread. Now, what is the exact use of the virtual thread? That you can understand with the next example. Let's just go for the next one. Look at this slide. Imagine here, I have a small pool, okay? 2 carrier threads are there. This carrier thread has this stack memory, okay? When the thread will be executed over here, like whenever a platform thread executed, it basically stores this information over here inside the stack. Like that, this carrier thread also got its own stack memory, and also this carrier threads are associated with one OS thread. Imagine there is a 2-core CPU, so we have 2 OS threads are available because we can run them parallelly. Okay. Now imagine here we have 2 virtual threads. Okay. Imagine I have started this virtual thread right now, which is virtual thread 1. Now this virtual thread will be mounted with your carrier thread. Okay. Now imagine this virtual thread is running right now. But imagine this virtual thread behind the scene doing some work, doing some task. What kind of task? Not any CPU bound task like running some normal Java code or running a loop or something. It's actually doing some IO bound operation. Imagine something like it is calling a third party API, like any microservices, or it is just making any REST call, or it is making any database call, which is blocking in nature. Because as I said, whenever you're going to make a call to any third-party API or any database, that's basically a blocking operation. That means if your virtual thread behind the scene is running some code which is doing some blocking operation, so after executing that line of code, if the virtual thread will go on blocking, right, where the thread will be ideal, not doing anything, just sitting and waiting for the response to come back for the call that it has made, at that time what will happen? This is the beauty of the virtual thread, and this is exactly the point that you need to catch. If the virtual thread is doing any blocking operation, this mounting that you have done, right, it will be simply unmounted. Okay. But as I said, the garbage collector will not eat it up because this thread is still executing, still waiting. The JVM will simply park this thread over here. Okay, the JVM will say, okay, now I know you are doing some work, so continue doing it work. So I'll free up this carrier thread, because using one carrier thread, I can only run one virtual thread on top of it. Well, there are so many others virtual thread we might have, so I will give this carrier thread to somebody else, right? Obviously, this virtual thread will be assigned to this carrier thread if it wants to run, because this carrier thread is right now freed up. But here is the point. Now you might have a wonderful question that, Avilash, if this virtual thread was previously attached with this carrier thread, right? And let's say it is operating over a method. And let's say inside that method that we might have a lot of variables, we might have a lot of references, addresses. And in the middle, if you are going to deattach that thread, where the virtual thread will keep those data, right? For an example, previously it was attached with this carrier thread and working on top of it. So all the method that it is executing, those method related variables data, it is going to store inside the stack. I know this because the carrier thread does have a stack, is operating on top of it. Right now, as you are deattaching this virtual thread and you are saying that, okay, let it run the code because it is making some blocking operation behind the scene, right? So in the middle, if you are going to park it and going to assign this thread over here, then in the middle of the method execution, whatever data that we have for this virtual thread, where it is going to store it. Now, that's the thing you need to understand. Whenever the JVM is going to deattach this virtual thread, it is actually going to take a snapshot of the stack. Okay, there will be a snapshot of the stack memory will be taken, and okay, now as I said, the JVM will take a snapshot of this stack memory which was available for this virtual thread and will be making it associated with this. Okay, so there will be a stack snapshot or memory snapshot will be taken. Okay, so it remembers everything this virtual thread used to hold till the time it has been like it was forced to park because it was doing some blocking operation behind the scene. Now this virtual thread 2, as this carrier thread is free, we can simply assign this virtual thread 2 on top of this carrier thread right now. Now the virtual thread 2 can execute over here. But here is the point. Let's say after some time, the virtual thread 1, which was doing some blocking operation behind the scene, that comes back. Okay, now it is ready to execute further because that blocking operation completes. Now what will happen? Now JVM will find the carrier thread to execute this one. Now the previously it used to operate over this carrier thread, but right now this carrier thread is busy because we have mounted another virtual thread over here. Now this virtual thread 1 will simply be given to another carrier thread to process the further execution. Okay. Now one thing you got to be clear, that when the JVM will assign the virtual thread 1 to this carrier thread, this carrier thread stack memory will be cleared, because there is a possibility as these carrier threads are getting reused, maybe one of another virtual thread might have executed on the carrier thread before, and that virtual thread might have used this carrier thread stack memory. So the stack will be clear, And this virtual thread 1 stack memory will be loaded into the carrier thread stack memory. Now this carrier thread knows exactly from which point this virtual thread needs to do execution. Because the virtual thread, when it's got parked, might have already done some part of execution. And then it might have made a blocking call, and that's why it got parked. But whenever it got mounted again with this carrier thread, stack snapshot that we have taken before for this virtual thread will be again loaded into the stack memory of this carrier thread. So this carrier thread can start doing the execution for this virtual thread 1 exactly where the virtual thread 1 left. So now it resumes and we can start doing the execution of the virtual thread 1 to complete the rest of its task. And then if they want to run, they will be keep on running. But once they are done running, once the execution completed, they will be unmounted. And let's say right now the executions are over and they will be simply gone from the heap memory because the garbage collector will eat it up. Okay. This is the beauty of the virtual thread. Whenever there will be any blocking operation will happen, the JVM simply will unmount the virtual thread and will park it until and unless the blocking operation completes. Once the blocking operation completes, the JVM will again mount it back to one of the carrier thread in order to make it run. Okay, so your CPU core will be keep on working, right? Because you might have hundreds and thousands of virtual thread. Let's say if you're doing some blocking operations, some threads are going blocking during the execution. You don't have to block. You don't have to, waste your CPU over here. You can simply attach the other virtual threads which need to perform their execution on top of these carrier threads. And now they will be keep on getting executed using the CPU core. That's why I said the virtual threads really signed whenever you are doing any blocking operation, because this gives you the power, like JVM is doing something like unblocking kind of operations internally over here, as you have seen, by doing that parking thing, right? So that's why people are so crazy about virtual thread, and that's why it is a revolution. And one more thing, guys, what would have happened? Okay, what would have happened? Imagine I have this virtual thread attached with this carrier thread right now and is executed, but let's say it is doing some blocking operations. So it is unmounted and the snapshot has been taken with the current stack. And let's say the same carrier thread has been given to another virtual thread which is running. Imagine we would have another virtual thread, okay, that is running, and that is running on top of this carrier thread. But imagine this virtual thread right now done with his blocking task. Right now it is available, right? Now it is ready to run the further thing. Let's say if this carrier thread is also taken up by another virtual thread, now what this will do? Anyone can guess? It want to execute, but no carrier threads available right now. So what will happen? It will wait. Exactly. It will wait to one of the carrier thread to be available. Once this is available, then that thread will be given to the carrier thread to do the further execution. As simple as that. Okay. So mounting, unmounting, and waiting. These three things are different. Okay. Wait, if it is going to wait, if this thread is busy, you can think like this virtual thread is on waiting state or in queued. Okay, the virtual, you will be hearing this term. The virtual threads are queued. Queued in the sense they are waiting for their terms to come. Okay, unmounted means they are unmounted and parked because they are still performing that blocking operations. Okay, queued means they are ready to run, but there is no thread is available. No carrier thread is available to run that. Okay, mounting means mounting with the carrier thread, and the current is gone. The power is gone over here.
We are not able to hear you.
Guys, there is a power failure here. Can you guys hear me now?
Yeah, Vilesh, we can hear you
Sorry,
now.
yeah. So actually my internet connection is gone. But everything made sense, whatever we have discussed today.
Yes, Ablash. Yes.
Yes, Vilesh.
Like perfectly fine, or like, I confused you guys? Just tell me honestly.
Yeah, it's perfectly fine, Abhilash.
It's clear, Vilas. It's clear.
Okay.
One question, Abhilash, for
Yes.
virtual thread, like, it will take fixed memory in the heap, or it
It,
will
it will
vary
take
based on how
it will take what, Mahesh?
fixed memory, like it is actually storing that
Yes, not fixed. So basically
stack.
for carrier thread only, we have fixed memory, right? So it will be using the carrier thread memory only.
Okay,
So,
so
fixed
in
memory
the
in the
same.
sense, Mahesh, whenever you are creating a thread, you actually can flag it, right? You can actually use a JVM flag, like how much memory you want for a thread to contain, right? Let's say by default it is 1 MB, but you want to assign less memory for a carrier thread, it is possible, right? So the virtual thread will be using the carrier thread's memory. So if you're just assigning 2 MB of memory or 10 MB of memory, you can also do that. But if you're assigning 10 MB of memory for one carrier thread, then how many carrier threads will be creating? Max 700 or 800 for 4 GB of RAM. I don't know if your operating system will allow you to create that many threads even. Okay.
Yeah, like so with virtual threads, we can create millions of threads in one carrier thread, right? With, within one carrier thread,
Uh-huh.
so we can create millions of virtual threads. So that means if
Absolutely. Uh-huh.
for suppose these millions of threads are still waiting for the third party communication, so
Mm-hmm.
they will end up in storing the stacked snapshots, right? So
Exactly.
again, the virtual concept is it's very fast, I believe. Like,
Yes. Yes, correct. But here
I
the
may be
only
missing
catch
one
is,
point here.
Mahesh, if you're, it's very easy to say we will be creating millions of virtual threads, but
Mm.
is it really required? And don't think like creating virtual threads doesn't have any overhead. Well, one thing you got to understand here is that there is no context switching is going on in the virtual thread, because there's just simply mounting, unmounting, right? There is no context switching is going on in virtual thread. In virtual thread, it's just like JVM is parking the thread if it is doing any blocking operation by simply unmounting it, isn't it?
Yeah,
So behind the scene, the context switching is not happening in the OS level. Okay. And that is why I can think like the virtual threads are fast and having less overhead than the platform thread, because in the platform thread, if you're assigning so many platform threads, then there will be context switching. You'll be creating 1,000 platform threads, but then the context switching will happen, isn't it?
yeah.
Yeah.
Okay.
So that's why that is one more advantages of the virtual thread, because on top of one carrier thread, as you said, you can create 1,000 virtual thread, and you can just mount it, unmount it, mount it, unmount it. If the blocking operations are going on, just unmount it. So it's just like
Mm.
a non-blocking IO call.
Thanks, Abhilash.
Whatever I said makes sense.
Yeah.
No?
Yes, Abhilash.